Okay, I will start with the introduction. Good morning and welcome. Thank you for joining to our webinar today on the use of food and feed crops for bio-based materials and the related effects on food security. I am Freya from nova-Institut and will introduce today's session. This webinar is part of a webinar series of the Preference project, which is coordinated by Avantium. And Preference is a 5-year flagship project sponsored by BBIJU to establish a new supply chain for FDCA and PEF. PEF being polyethylene furanoate, and a completely bio-based and recyclable polymer with many applications, for example, plastic bottles. Today, Lara Dammer, the head of the Economy and Policy Department at nova-Institut, will give you a deeper insight about the latest research on food and feed crops for bio-based materials. After her presentation, there will be at least 15 minutes for questions. And please, for this session, put your questions before in the Q&A box and not in the chat. The webinar is being recorded and the recording will be available to you today or next week. I will share a link with you via the email that you used for the registration. Okay, I wish you a nice session. Lara, you can start.
Thank you, Freya, for the kind introduction, and good morning also from my side. I'm happy to present some of our latest research. And for those that don't know nova-Institut, I brought just a very few slides of introduction. And now, yes, it's working. Great. So nova-Institut is a partner in the Preference project. Freya is handling dissemination and communication. And as an institute, we are actually doing a lot more around these topics of bio-based materials. For example, we are independent and working in a lot of national or international research projects, but also doing a lot of consultancy for companies and organizations. And our main topic is how to get away from fossil carbon in chemicals and materials. On the bottom right, you see our logo on renewable carbon, which summarizes this approach. And I will go into that in a little bit as well, because it is related to the topic of today's session, of course. We work in 4 main departments. On the right side, you see the communication and the economy and policy department. So Freya and we are representing those. We work a lot in dissemination and communication in projects. We have our own conferences and events. We do a lot of newsletter work. We publish a lot on our own platforms. We work on social media. And my economy and policy department, we analyze policy frameworks. We do consulting for companies on what the new policy frameworks under the Green Deal, for example, or the circular economy package, what they mean for companies and for placing products on the markets. We look at what is hindering bio-based economy, for example. We work a lot on standards, certification and labeling, micro and macroeconomics too. So, for example, monitoring the bioeconomy is one of our long-time activities. But we also work on techno-economic evaluation of specific processes, especially innovation or innovative and young processes. We also have a technology and markets department at Nova. They are very up to date on current trends, how markets are developing. We publish several market reports per year. We do innovation and technology scouting and more. And last but not least, our sustainability department does a lot of LCA also for the Preference project, for example, but also in a lot of other contexts. And carbon footprint studies, more holistic sustainability assessments, EPDs whatsoever. So we cover a broad range of accompanying research for innovative and environmentally friendly new products. Just a brief hint, you can check out renewablecarbon.eu. We publish a lot of stuff for free. You see the pink gems up there on publications and graphics, for example. We have a news platform. We have a lot of events. So just a recommendation to check it out to find out more about these topics that we are talking about. And this is a brief hint on the conferences. Of course, now my phone is ringing. I'm sorry. So just a brief hint also on our conferences already next week. We will have the Advanced Recycling Conference. It's still time to register. You can also join online if you want to be spontaneous. And a very warm recommendation for the big Renewable Materials Conference also next year in Siegburg, near to Cologne. It's our biggest conference, and it also combines all kinds of sectors. And it was a very, very inspiring event this year, this summer. So to go into the topic of today, it's actually an extract of a publication that we had worked on for over a year between 2022 and 23. It was published finally in June. And we have been, it is a synthesis of a lot of years of work that we have actually done on the topic of food and feed crops. Basically, what we wanted to investigate is whether the claim that the use of food and feed crops for any other application than food and feed is bad for food security, because this is often an axiomatic claim. People just say it and it sounds very logical. If you don't use it for food, then there is less food, so there will be more hunger in the world. So using food and feed crops for anything else, may it be fuels or bio-based materials, is just bad. Actually, the situation is much more complex, and this publication and now also the webinars and sessions that we do on the topics, they are also a plea for a more evidence-based debate and to treat this complex topic with the attention that it actually deserves before we make any such claims. RCI stands for Renewable Carbon Initiative. So this is a group of companies. Nova-Institut founded this initiative. By now, I think it has more than 60 members or something like that. And it's going forward without clicking. It's a combination of big chemical companies, but also other large suppliers of SMEs. You see here some of the Preference Project partners. Avancium as a coordinator is also a member of the RCI. And I will talk a little bit later about the renewable carbon topic also and how it relates. So you see here also brands and startups. And this initiative, no. There's an automatic, sorry, I don't know why the slides are suddenly going automatically. So this initiative wanted to have a deeper look into the topic that I mentioned on using food and feed crops. So this is why this was funded by the RCI. Let me start that we took an approach to look at the reasons for hunger that are being published by the experts, basically. And one thing that we came across again and again, that climate change is, next to COVID and conflicts, the most important reason for hunger in the world already now. You see this in the World Food Programme, you see this in IPCC reports, you see that in repeated FAO reports. So the evidence is quite staggering. And if we go even further, if average global temperatures will rise, there's expected that an additional 189 million people can be pushed into hunger with a 2% increase, a 2-degree increase, sorry. And in a 4 degrees Celsius warmer world, this figure could even rise to a staggering 1.8 billion people. Of course, these models, they have a lot of insecurities, so it's really hard to say, is it going to be 100 million, 200 million, 500 million people, but the numbers are extreme. So we already see that climate change is one of the core adversaries also when we want to fight hunger in the world. And I think the conclusion that all solutions that mitigate climate change are important in the fight for more food security. And why is this important for bio-based materials? Actually, to mitigate climate change, we need to end our dependence on fossil resources. 70% of all greenhouse gases that are contributing to global warming, they originate from fossil carbon. We have some contributions from land use changes, for example, or from agriculture, but the big majority, 70%, comes from fossil carbon. To end this dependence, we need to decarbonize in the energy sector, so switch to wind and solar energy. But in the material sector, this is not possible. Organic chemistry needs carbon. It's part of the molecules, and it will always be part of the molecules. By the way, humans are also made of carbon to a large degree. So this word decarbonization in every area as a strategy for climate change mitigation, it doesn't actually work. If chemicals and materials are not collected and recycled at their end of life, the embedded carbon, the carbon which is part of the molecules, will be set free. For example, if the products go into incineration, but also if they degrade somewhere in uncontrolled environments. I will show a graph in a minute that this is about 2/3 of the product-related carbon footprint, actually, the embedded carbon in the materials. This is why we cannot decarbonize, but we need to shift to alternative carbon sources. And we call these alternative carbon sources renewable carbon. It's the equivalent to decarbonization, and it can be called defossilization, which is actually the term that we prefer nowadays, because you don't decarbonize, but you still move away from fossils. This is what I meant before. This is, we calculated for some bulk chemicals. Of course, there's tons of chemicals. You can do that for a lot more, and sometimes the numbers may be a bit different, but here you see the different carbon footprints. The blue part is the one from the embedded carbon, and the white one is from production, from the process emissions. And you see that roughly 2/3 of the carbon footprint that is caused by these kinds of chemicals and materials is actually from the embedded carbon in the molecule. So this actually counts. It's not a small part. Just a brief focus on what are all alternatives. We can directly use CO2. We can capture CO2 and use it again, of course, only with the help of renewable energies and green hydrogen if necessary. We can use biomass, which is today's topic, and we can directly recycle, which is, of course, also interesting, related to a lot of bio-based materials, including PEF. So in the end, renewable carbon entails all carbon sources that avoid or substitute the use of any additional fossil carbon from the geosphere. So the geosphere is everything that is below the ground within the Earth. We do have the atmosphere, where we can capture CO2, for example. We have the biosphere, where we can harvest biomass, or we have the technosphere, which also includes, for example, direct CO2 emissions from installations, or we can take the carbon already in materials, which would then be recycling. So all of these together are needed to replace fossil carbon, and bio-based products play a role in this. Today, this is just one graph from a big carbon flow study that we did. We tried to find out how materials and chemicals are, what they are made of today. And here we see that today we still have a fossil carbon share of 88%. So that also means that for all the other solutions, bio-based, recycled, and CO2, there's a lot of space to further develop, and it's needed that they further develop. Because in addition to that, we also see that within chemicals and materials, the demand for carbon will actually increase. In energy and transport, of course, we can decarbonize, and then we can cover the rest, maybe also from alternative sources, which also means that the relative carbon footprint of chemicals and materials, which is not super high today. If you look at other sectors, energy and transport, they have heating, buildings, they have a larger impact at today's greenhouse gas emissions. But the relative impact of materials and chemicals will increase strongly, because here the demand is growing, and in the other sectors it's decreasing. So all of that together is really a call for action that we need bio-based materials. You may wonder why I put such a long part of that in front of today's topics on food and feed crops, but the thing is that we need to be clear why we actually need bio-based products at all, because you could just say, well, we just don't do these products, so we don't have the feedstock question. But if we don't go for bio-based products at all, we will remain with a 88% fossil-based system, which causes today's problems, or it will become even more. So this is really crucial. It will help to mitigate climate change, and this already is a big step in the fight against hunger worldwide. The second question, which is crucial, is how much biomass can we use at all? Because this is obviously the core question of the whole discussion around feedstocks and resources. Actually, the competition for biomass is not about which crops to use, but how much biomass there is in total, because this is related, and this is related to the limiting factor, land. How much area do we actually have that we can use to grow sustainable biomass? This is the limiting factor, not whether a crop can be eaten or not. It's going to be challenging, that is already clear. It's really hard to say how much more food we will need. The estimations are that by 2050, the world population will grow to circa 9.7 billion people, give or take a few. This is not a growth by 50%, but it's expected that we need to produce approximately 50% more food by then compared to 2012. And this is related to increasing wealth also. A lot of people around the world eat more meat nowadays, which needs a lot more resources to be produced. So we have huge growth in food demand, and how we can cover that is a big question, of course, because this needs to be the top priority in biomass use. Today, you can see the use of global harvested agriculture and grazed biomass goes mostly to feed for animals. In total, we have 72% of agricultural land being used for animal feed. Circa half of that comes from agricultural land, from cultivated biomass. The other half comes from grazing of green land. We have an additional 16% of biomass being used for plant-based food. So in total, this is already more than 3/4 of global biomass demand. Then we have a relatively big sector for bioenergy and for material use, both 5%. Liquid biofuels is at 2%. And just for fun, we included the current demand for bio-based polymers, which is less than 0.1% at 0.032, which is really, really minuscule, as you can see. And just as an add-on, we also included some numbers for first and second generation and polymers. And here you see that polymers are already made from different kinds of resources, but I'm not going into that in too much detail today. So one really crucial question is also how we can increase the potentials for sustainable biomass availability, and we do have several options for that. We need to increase yields. We can do that through traditional approaches like intercropping, agroforestry. I think there is quite a bit of movement to go back also to some of these older techniques and to make agriculture more sustainable and more effective. But also innovative approaches are really important, and they will become more important. Breeding, biotech, and agrotech, like precision farming, for example. We still seal, I think, 0.6% of land every year in the EU, something like that. So we could also think about smarter housing and industry planning to prevent such land sealing, not to lose more area. Using marginal lands with resilient crops could be potentially interesting. We have quite a bit of land worldwide and in the EU, which is becoming more and more degraded due to unsustainable farming practices, but also due to climate change, droughts, and so on. So we have more marginal lands, and how we can still keep them in production is, of course, an interesting question. It is not easy. It's hard to make that economically feasible, but it should still be considered and probably also improved. Then one of the biggest levers we had, because you saw the numbers on land use and meat consumption, is that if we reduce meat consumption, actually big areas of land will free up. So this is a very important tool, but I know it's also quite controversial. However, I think we need to state the facts that this is actually has a big impact or would have a big impact. Same for reducing food waste. We still waste 30% of food worldwide and in the EU. It happens in different stages of the value chain, depending on where you are. But here, actually, consumers throw away more than what is lost in the beginning of the value chain. But still, in total, we lose 30% of food. And that could be, if that could be improved, we would actually also free up a lot of areas for other things. We still needed quite a few acres for biofuels. That could be reduced if energy policy develops. We see that the expected demand for car transport, for example, will go down, or in general for liquid fuels for road transport. However, of course, now we have suddenly very ambitious targets for aviation fuels. It remains to be seen how that will be covered, whether that will be covered from biomass. At the moment, it is not foreseen that aviation fuels can be made from primary biomass coming from agricultural land directly, but the final word hasn't been spoken. So it's hard to foresee how the demand for biofuels will develop and how much area that will actually cost. And then, of course, we harvest biomass and we could use it more efficiently to make more of what we already have. And for that, we will need probably more innovative processing technologies, better processes on how we can use the separate fractions, the different fractions of biomass, for example. These are a few factors that can have an impact. And I think they are really important to keep in mind and to keep in mind also for a holistic policy development on biomass and biomass availability. Coming to the paper itself, we looked at the evidence base for this claim that I mentioned, that it's per se bad to use food crops for anything else. And I have to say that the evidence is not very strong. It's super complex. You have a very complex system globally for food trade, for food speculation. You have huge dependencies of smaller, poorer countries on huge global conglomerates and companies. And this whole debate is based in the 2008 food crisis that was relatively soon after we had huge incentives for biofuels and bioenergy. At the same time, there were problems with harvests, there were problems with storage facilities, there were problems with speculation. But the thing that remained in everybody's heads was that the biofuels were stealing the food from the poor people. However, even the rapporteur on the right to food of the UN concluded that the situation was much more complex, and there is very few in terms of sources that see a clear connection and that can actually prove that connection. On the other hand, what we try to establish is that it's not per se bad, and that if it's done right, it can even have multiple potential benefits for the planet, for food security, and so on, if food and feed crops are used for bio-based materials in a sustainable way. I already mentioned climate change mitigation, but we also saw that land productivity is actually much better with food and feed crops. I have slides on that in a minute as well. The environmental impact is not bad per se at all. It really depends also on the agricultural practices. Farmers and market stability can actually profit a lot because they have multiple outlets for the crops, not just the food and feed markets, but also now maybe chemicals and fuels, also depending on the quality of their harvest in a given year. And we increase feed security through protein-rich byproducts, for example. And we can also increase food security in times of crisis, because you can actually work with emergency reserves. If you have certain areas grown with food crops for industry, in a real crisis, you can redirect those crops. If you work with non-edible crops on agricultural land, for example, in short rotation copies, then that is not possible. So we have potential benefits. I'm saying potential because, as mentioned before, the situation is complex. It's not easy to predict how something will get out, but I want to show a few more facts on food and feed crops. I talked about land productivity. In a study a few years ago, we actually compared the yields of different crops that can be used for fermentable sugars. So we compared first generation sugar beet, sugarcane, wheat, and maize with the so-called second generation that are from forests, or, as I mentioned, short rotation copies. The SRC on the bottom right means short rotation copies, which you can grow on agricultural land or on marginal land, but then the yields are even worse. And what you see here is that with the first generation, you have much higher yields of those fermentable sugars that you need for chemicals, for example. And you can combine, of course, the first and the second generation, because you also have cellulosic byproducts such as leaves or stalks or straw. So the actual land use figures are much better. Of course, the impact on food security is not easy to compare when you look at forests versus agricultural land. But just looking at the pure land use, we see here that the high input, high output system of agriculture yields a lot of feedstocks to work with. In terms of environmental impacts, we did a nice comparison, because actually the use of agricultural land for cotton, for textile fibers, is not controversial at all. It's really traditional. It's cultivated on huge areas worldwide. But if you compare that, for example, to textile fibers made of PLA from sugar or starch crops, the PLA fibers perform much better in a lot of categories. They need much less water. They need a quarter or half the land for the same amount of fibers. They have a lower global warming potential, and they only need slightly more energy. So this direct idea, cotton for textiles is good because we cannot eat it, and PLA from sugar or starch is bad because it robs us of the food and feed crops, is too short. And I think this really shows that the simple answers don't do justice to this complex topic. Another thing that I find extremely impressive is that corn, or I think the next one is on rapeseed, yes, they have a lot of byproducts. So you don't just use the starch or the carbohydrates for food and feed or the industrial applications, but at the same time, you have 30% protein and fibers that will always go to the food and feed market. And with that, you can replace also a lot of soy imports that are related to a lot of land use change problems. So it's actually not a bad idea to grow more of these crops on European soil to substitute these kinds of land use imports also for the protein sector, because, as I mentioned before, 72% of land use actually go to the animal feed sector. So what we can substitute with homegrown sustainable crops would actually help a lot. With rape, you have an even higher amount of straw of the byproduct, but even that can be also put into applications. And here you see that oil and protein make up for 70% of the feedstock of the resource. So that is extremely valuable also for different sectors, but also for the industrial applications. One more thing is that the use of food and feed crops for materials is really old. It's not such a new idea. It has come more into the focus because the traditional sector is also, it's stable, it's stagnating, but of course we now want to improve and to grow the bioeconomy. So some changes needed. So the focus has also shifted, but it's often forgotten that, for example, already worldwide, we use 12.4 million tons of starch in paper. And this is starch that comes from wheat, from corn, from potatoes, so from food crops. And it's never been contested that this is actually a good idea. And we did some calculations. As I mentioned, we also do some monitoring and macroeconomic analysis. And we calculated from Eurostat figures, from production figures, that we calculated the amount of chemicals that is bio-based. And then out of the bio-based chemicals, we calculated that the share of food and feed crops used for these ranges between 50 and 60%. That results in an overall amount of 11.4 million tons of first-generation biomass used for chemicals and a corresponding 21.2 billion euros turnover. And in the pharmaceutical sectors, which is separate from the chemical sectors in the statistics, this is even higher because you don't use second generation for pharmaceuticals. So here we assume the share of food and feed crops to be around 90%, which results in a staggering 146.1 billion euros of turnover. So in summary, we already create turnover in the amount of 160 billion euros in Europe by using food and feed crops for chemicals and pharmaceuticals. We often have these very strong arguments or statements by policymakers that no food and feed crops should be used for chemicals, and they completely forget that it is already done and that it would hurt a lot of industries not to do so anymore. And also, actually, what would be the alternative then? We would use more fossil carbon, so that also doesn't seem like such a good idea. I think this is my almost last slide. This is also from an older study that we just brought in here again. Back then, we did a traffic light sustainability risk evaluation of different feedstocks, also first generation versus second and third generation. And of course, you have, and what it shows is that you have problems, or you have higher risks and lower risks for each crop, depending on where you are and what you use it for. And what I find, for example, quite interesting, also the biodiversity issue, you have that both on agricultural land and on planted forests, for example, or highly managed forests. So in both systems, you don't have a lot of wildlife anymore. You leave basically nothing to chance. You have different impacts on GHG footprint. Here, for example, the waste and the residues perform much better, of course. But on the other hand, we also counter-calculated that with the level of subsidies that you need to actually make them feasible, and they are really, really high, which means that the total costs for GHG abatement are also worse than if you do the same, for example, with first generation crops. So the picture is quite complex. I think I've mentioned that before, but it's really a message dear to my heart. Complex questions don't get simple answers, and if they do, they are mostly wrong. And I think this is important to keep in mind here. And I really like this quote from a WWF study also on bioplastics feedstocks. And they said that the bigger picture is not the specific issue of whether food or non-food crops are being used to produce biomaterials, but rather the integration of any feedstock for biomaterials production into a landscape and its social, environmental, and pricing effects there. And my personal conclusion is that the choice of feedstock in any given case depends on many factors and is site-specific, and there is no one-size-fits-all solution. Thank you very much for your attention. I'm really happy to answer some questions now. I'm looking at the time. I think the timing is really perfect. Just if you want to learn more on some of these issues, We do also have our own webinars. I posted some dates here on the last slide. I think Freya will send around the slides also, so you also get my contact if you have later questions. Yeah, we will talk a lot about LCA, about green claims, but also on food and feed crops in the next few months in some of our NOVA sessions. So happy to get some questions now.
Thank you, Lara. This was really interesting. We also have a lot of questions, so I hope we get through them all, but if we don't, we will answer them later via email. The first question was, you mentioned we will need 50% more food in future, then also mentioned meat. Do we need more food or more food and especially feed?
I think both. So the question is, of course, how the food demand will develop in overall volumes. So let's say per calorie intake, that will hopefully grow because people will hopefully have more food and more healthy food in certain parts of the world. But on the other hand, it is expected that the consumption of dairy, of beef, of pork meat, that will all increase. It's really hard to predict how dietary patterns will evolve. I already also read some discussions that actually in industrial countries, the curve will have to go down again because we will basically destroy our health systems if our diets keep developing like this. But it's really hard to say. It's really hard to predict. So yeah, if especially the feed demand will also develop, this means that the overall demand for land and for biomass develops even steeper than the overall calorie intake.
Then there's a question which is a bit out of topic. Do you think lab-grown meat could be a solution to decrease the land use for feed? Or will
it's not really out of topic. I think it's quite related. Yes, I didn't mention it today because it's not one of the core topics, but if acceptance and productivity of lab-grown meat increases, it would probably be a helpful mitigating factor. Let me put it this way. I also now heard about dairy, lab-grown dairy products, for example, that could replace cow milk, apart from plant-based solutions to replace cow milk. So yes, that is, of course, also part of the puzzle. I'm not 100% sure how much land use that will actually how much land that will set free. But yes, I think it will be part of the solution.
Okay. Someone is asking, why is there no notion of time of use versus renewing period in the renewable carbon definition? To have an impact on global warming, CO2 needs to be stored for a sufficiently long time, about 100 years.
This is actually off topic. This is super complex, actually. Yes, overall, if we keep more products in use and store the carbon within them, that will probably have an impact. But that is not just important for bio-based materials, for just saying, because it's super complex and I don't have any graphs with me to illustrate. So the time of use is hard also to calculate and to integrate into scientific methods. It's really not easy also to get it into LCA, as far as I understood. So it's not in there for now. But we do have recycling in there, which is also quite important, I think, when we think about the whole life cycle. Sorry if that answer is too short, but it's hard to cover that now just from the top of my head.
Expected loss of 9 million tons of crops in Spain due to drought this year. How can you make sure that yields of crops will continue to increase in the future?
How can I make sure? I'm not sure if I want to take on that responsibility. No one can make sure that that is the case. I have been actually looking into a lot of biomass predictions lately because we are working on a big biomass potential study also with the RCI. I was also surprised if you look at the FAO Global Agricultural Outlook or at the EU Agricultural Outlook, they expect tremendous increases in yields still, I think mostly due to breeding and improved performance of the crops. And I personally think that the effects of droughts and of climate change are underestimated so far. So far, we have relatively optimistic projections. It's really hard. No one has the crystal ball how this will develop, and I think we need to work a lot on making agricultural systems more resilient. But I can't tell you what will be the solution. However, I actually think, because I'm not sure how this crop is completely lost or whether it doesn't fulfill food requirements. For example, in Germany, we had too much rain this year, so the wheat harvest was actually bad in many parts of Germany, and the protein content of the wheat was not high enough to qualify for food grades. So here I would actually think that additional outlets from chemical industries, for example, would help farmers not to lose out completely on their harvest. So far, they are also quite happy that they can sell to the feed market if the wheat isn't good enough for bread. But chemicals and materials as an additional outlet wouldn't hurt either, I would say.
Somebody asks, why not potatoes in this sugar starch yield slide? Potatoes have a significantly lower CO2 output per kilogram. I think you used rapeseed and...
Well, yeah, potatoes are not a part in either of the graphs. I think so far potatoes are used to very, very limited amounts in industry. I think just the starch for paper, as far as I know. With potatoes, you have the issue of an extremely high water content. So comparing the total harvest to the actually usable fractions, potatoes perform worse than other crops like corn or wheat. Sugar beet also have a high water content, of course. I'm not sure. It's just not in the main focus mostly of material use, which is why we haven't included it. I know it's in some other publication, it's in there, but this doesn't mean per se that potatoes are not usable, but it's just not in the focus, I would say.
Okay. Considering the table on sustainability risk evaluation, do you still believe differentiating generation 1 and 2 and 3 are still to be considered?
Good question. The terms are out there. They are pretty well known. But it's also, if you look into the details, it's also really hard to distinguish or to draw a line between first and second and third, especially. Not necessarily, no. You have to handle the terms or some groups for some reason. In the paper, we try to make a definition also, but there we refrain from using first and second and third. As I said, the table is from an older study. This time, we differentiated only between food and feed crops versus non-edible parts or non-edible crops.
What is the source for the global harvested agri and grazed biomass demand by sectors? Somebody feels that biofuels are a bit low. I think the source should be...
Yeah, no, actually they are not too low. The sources are from the FAO statistics mostly, as far as I know. I would have to check also. But mostly FAO statistics. The biofuels are actually not too low, but what I think is a problem here is that the material use is, we are working on that figures as well, because the material use is estimated quite high here, because we also have a lot of straw for animal bedding, for example, and these are huge volumes worldwide, but it might distort the picture a little bit. So actually 5% bioenergy is accurate because a lot of wood is still used worldwide. Oh no, wood is not in the picture. This is mostly then biogas or other heating, I would say. And the liquid biofuels, they don't make up such a huge share of agricultural biomass use worldwide.
Thank you.
You can always go to the original source, of course, to the study, to the paper. All the sources are in there as well.
Yeah, and it's also for free downloadable by our website, renewablecarbon.eu, I think.
Of course, yeah.
Is there a calculation on how much land we actually need if we want to transition all annual current plastic output with bio-based?
There's a study from Wageningen University. They did that. If you were to go, so 100% of plastic production worldwide would use 5% of biomass worldwide, I think is their conclusion.
So 5% of biomass that is currently produced.
Yeah.
Somebody is asking, your case with global or EU are very convincing, thank you, but do you have continent or country specific data, for instance, how the situation looks like in USA and China?
Which situation? So actually, no, we don't have any of those, but it really depends also on what you are now thinking. Land use, for example, I don't know what this refers to. But no, it wasn't in the focus, and it is a lot of work actually to compile all of these data. And also now with the biomass study that we're doing with RCI, we will do global scenarios and EU scenarios, and there we are working with the Capri model, and within the Capri model you have regionalized data on crops, on yields per worldwide region, so you can also make some differentiated assumptions for different regions of the world, but it wasn't in the focus of this study.
And this publication will also be
yeah, let's hope next year, middle of next year. That's my optimistic guess now.
Then somebody is asking a related question. How do you compare biomass from different countries? Growing corn in US and Brazil and China is not having the same impact. Should we differentiate sourcing by production area?
As I said in my conclusion slide, basically, yes, of course, you always need to look into the regional context and what is the best crop in any given context and situation. So what we showed here is some exemplary data. We looked whether there is substantiation for this general claim that using food crops is always bad. And this could not really be substantiated. And instead, we found a lot of hints where using food crops could actually be helpful. But if that is a case in a specific situation or in a specific region, that needs to be assessed on an individual basis, which is what I tried to convey also in the last 2 slides.
The residues return to the ground to amend their regeneration. If tomorrow we divert their function for plastic production, what would be the consequences on yields?
Yeah, that would be disastrous. So thank you for that question. I didn't mention that, but in some calculations, also now the biomass study I mentioned, we always estimate that at least half, if not 2/3 of the residues will remain on the soil because we need it for nutrients and for regeneration of the soil. That is completely clear. Which is why I am also quite hesitant when I now read certain policy documents that only want to make use of residues and wastes. I think the logistics will be extremely challenging because availability is more limited than I think most people realize, both with waste collection, but also with harvesting residues left on the ground. So we cannot utilize it all, that is completely sure.
Something again about lab-grown chemicals and materials. Do we know how efficient fermentation-based chemicals and materials are compared to conventional fossil fuel-based processes like the conversion of sugar to polymer versus the conversion of crude oil to polymer?
Yes, that is known. There is a lot of information out there, but this is not my topic today. And you always need to compare product to product, process to process. And it just in general, fossil resources have super condensed carbon content because they have been in the ground compressed for millions of years. So being more efficient is not the only aspect that we need to consider.
I think this question is also kind of too big, but will there be a regulation for material producers? Example, code of conduct defining which feedstocks and where of the food feedstocks we can use, for instance, World Hunger Index, land change, deforestation for certain locations and areas?
Good question. Actually, I have a whole presentation on policies for biomass use and what kind of regulations there are and what can be expected. That will be part of our food and feed session, actually, that we are hoping to repeat in early 2024. At the moment, I don't see a comprehensive regulation for biomass. So to make a long story short, at the moment, I don't see a comprehensive regulation. There might be some product-related ones, and what exactly they will contain needs to be seen. We have some hints from the policy framework on bio-based plastics, biodegradable and compostable plastics, for example, from the Renewable Energy Directive, from the taxonomy. But as I said, this is a whole presentation, and I'm happy to give you information on upcoming webinars if you want to delve deeper into that.
Yeah, I think the information where you can find these sessions is also in the slides.
Yeah.
Hi, Lara, do you have statistics on the development of production of lupins in Europe?
Of what? Production of what? Lupins? Lupina? No. Hey, thank you for the question, but I don't have that at the moment, and I don't have that in the study. Yeah, I think leguminoses, I don't know the exact English term, but they will also play a role for protein supply, for example, but I don't have any recent numbers or statistics. I'm sorry.
Okay, and the last question, any action by Nova that LCA should include biogenic carbon absorption in cradle-to-gate LCA or carbon footprint?
Yes, we also have activities on that, also in the scope of the Renewable Carbon Initiative to a large degree. Please contact me separately on that. This is a huge topic again. We are involved in that. We are publishing papers and opinions on that, and we are in direct touch with the Commission and the JRC on that to hopefully also have some impact on the discussion and make it go into a good direction. But yeah, as I said, feel free to shoot me an email and I will try to connect you with the right papers and the right people, maybe.
Okay. Thank you for answering all of the questions. There are some in the chat that we didn't cover yet because, yeah, but I think, yeah, we answered most of them. And yeah, thank you, Lara, for the presentation. We will follow up with an email and send you the link to the recording and also the slides as a PDF file so that you will have Lara's contact for further questions. And yeah, thanks for joining.
Thank you very much also from my side.